Welcome to the notes on surface area of prisms and cylinders. Okay, so we're going to talk about what surface areas and then what prisms and cylinders are. So we're talking about prisms, all right. Mostly we're talking about, we've got these things called faces, all right. These are the faces, okay, and there are several on there. And then we're also going to have this thing called bases. Now this is not technically, all right, a prism or a cylinder, but this is but we're gonna use this terminology. So faces and bases. Now again, base does not always mean bottom, but in this case it is. So what is a prism? All right, a prism is a solid, okay, with a pair of congruent sides or congruent shapes, and those shapes are parallel. Okay, so we'll kind of talk. Here are some examples. Okay, prisms are named by the shape of the base. All right, you guys can see some of these base does not always mean bottom, but this right here, all right, the base, okay, would be called a rectangular prism. This, okay, these are the two congruent shapes and they're parallel to each other. That would be a triangular prism. This would be a hexagonal prism. So you can see we're going to have to find, we're going to have to still use the apophyton to find the area of those shapes. Okay, rectangular. Again, base doesn't always mean the bottom. Okay, you can see from these examples. So how are we going to find surface area? Well, it's really pretty simple. You are just going to add all the faces, add all the area of faces and bases together. All right, that's it. All right, you're going to look at all those shapes. We know how the formulas for each shape. We're just going to add them all together. So it's kind of like perimeter. There really isn't a formula. So this first example I like. It breaks down all the different. It's a rectangular prism, and it breaks down all the different rectangles. So the front. Okay, I'll do that in red. That's this rectangle right here. All right, call it the front. We can see that that's 9 by what's the height? It's 11. Okay, because again, base times height. All right, so that's 99. The back is the same shape. So again, it's 9 times 11. That's going to equal 99. Let's do a side. Okay, here it is. Well, you can see that that one is going to be 11 by 5, or 5 by the height of 11. So there's 55. Same with the other side. 5 by 11. 55. And then the top and bottom. All right, sorry, going the wrong way. All right, top and bottom, do those in green. You can see that that's going to be 9 by 5. And there's your 45. There's your 45. So then all you're going to do is you're going to add all these together. And when you do that, okay, you should get, this will all equal 398 square inches. And that is the surface area of this object. So pretty straightforward. Okay, let's take a look at this one, a little bit more difficult. But again, we've got the front triangle and the back triangle. So let's do the front triangle first. All right, that's this one right here. Okay, well, it's a right triangle. We know the base and the height. We're just going to divide it by 2. So that's going to be 12.2 times 4 divided by 2. That's how you find the area of a triangle. And when you do that, you're going to get 24.4. Well, guess what? That's going to be the same as the triangle in the back. So I'll say back triangle equals 24.4 as well. Okay, now let's find some rectangles. Right, we got this. Which one do we want to do first? Let's do the bottom one. All right, we're going to go bottom rectangle. Okay, and that's just going to be 4 by 6.5 inches. All right, that's going to give us 26. Okay, then we've got the left rectangle right here. Okay, you can see that that's going to be, looks like it's got 12.2, and that's going to be by 6.5 inches. And when I do that, that's going to be 79.3. 79.3. Okay, so now we need to erase some stuff. So here's where it gets a little bit more difficult. Okay, we're going to try to find this piece right here, right? This rectangle. Okay, we're going to call that the right rectangle, or right, yes. All right, now to get that, you can see that we don't have this piece right here. But guess what? It's part of a right triangle. So we can find it by using Pythagorean theorem. So I'm going to kind of just do that over here. I would say 12.2 squared plus 4 squared, and that's going to equal, all all right, x squared. Now, if you do that correctly, you should get x is going to equal, you guys know how to do Pythagorean theorem, you should get x equal to 12.94. So this value right here, I'm going to erase this triangle, x is going to be 12.94. So now you can see that I'm going to take 12.94 and I'm going to times it by my 6.5. And when I do that, I should get 12.84, sorry, 84. And when I do that, I'm going to get 83.53. Now I'm going to add up all these values, 83.53, 79.3, 26, 24.4, 24.4. When I add those all together, my surface area of this object, right up here, is going to equal, all right, 237.63. And that would be inches squared. So that is how you're going to find the surface area. Just add them all together. Okay, now, cylinders, a little bit different, all right? You notice a cylinder, it's got two circles, right? It's got one at the top, it's got one at the bottom. So we're gonna have two literally circles, all right, plus this lateral face. Okay, now this lateral face, okay, it's kind of this piece right here, okay? If I was to cut this along the dotted line, all right, this, believe it or not, would actually roll out into a rectangle. Okay, where you can see that this would be the height, but this distance across the top would actually be the diameter. If I cut that out, this right here would be the diameter. So how would I find the diameter? Well, diameter is, or circumference, excuse me, that's actually the circumference. And remember, circumference equals diameter times pi. So this is just diameter times pi times height. So there is actually a formula for these. It's the area of a circle, but there's two of them. So it's going to be radius squared pi, but that's going to be times 2, right? Plus the area of this kind of lateral face, which is just diameter times pi, d pi times height. So this is the formula for a surface area of a cylinder. Now we know that, we can just simply solve these problems. Okay, so I'm going to have this 2 because there's, again, surface area of the cylinder is going to equal 2 times the area of a circle. Well, we said area of a circle is radius squared, so that's 8 squared times pi. All right, and then we're going to add that. We're going to plus, all right, the diameter times pi, so that'd be 16 times pi times the height of 17. And that's it. So when we do that, we're going to get, on the bottom here, we're going to get 64 times 2 is 128 pi, plus 16 times 17 is going to be 272 pi. Combine those, our final answer, surface area is going to equal 400 pi, and that's square feet, as the total surface area, just adding up all of those values. Okay, the example 4 is no different, except now, all right, the cylinder is lateral, but we still have our surface area is going to follow that same formula. So surface area is going to equal our 2, all right, but that's going to be times the area of the circle. Well, since this is 12.5, we know that this radius is always half, so that's going to be 6.25. So it makes it a little bit more difficult being decimal, but we'll just keep everything in terms of decimal. So it's 6.25 squared times pi, plus, all right, the diameter, which we already know is 12.5 times pi, times the height of 20. And there it's, once you know those values, type in your calculator, your final answer. All right, just use that calculator. It is going to be a decimal. You're going to get 1,030.84, and that's going to be square centimeters. So surface area is just adding up all the bases and the faces together using our formulas for area of two-dimensional shapes.